All right, let's talk about something that's a total game changer for any serious C# and .NET developer: design patterns. Seriously, if you want to write code that's not just good, but professional and high quality, this is pretty much the secret sauce.
So let me ask you this. You start a new project, right? Everything's clean, organized, beautiful. But then, a few months down the line, it's just a mess. It's this tangled web that's a nightmare to work with. Adding a new feature feels like a game of Jenga, doesn't it? You're just praying the whole thing doesn't come crashing down.
And look, this isn't just a minor annoyance, is it? We're talking about real consequences. More bugs, development grinding to a halt, and that sinking feeling in your stomach when you get a ticket for a part of the code you haven't looked at in forever. But here's the good news. There is a much better way. Okay, so what are we talking about here? What is a design pattern? Well, think of it like this. It's a reusable, battle-tested solution to a problem that developers have faced over and over again. It's not a library or a framework you can just plug in. Nope. It's a concept, an idea. It's like an architect's blueprint for your code, showing you how to build something that's solid, clean, and actually makes sense. So, here's what we're going to cover. First, we'll talk about why this whole blueprint idea even matters. Then we'll dive into building objects smartly, assembling them with flexibility, and managing complex behaviors. And we'll wrap it all up with a look at your new pattern toolkit. All right, first up, the architect's blueprint for code. Let's really dig into why these patterns actually matter so much. Okay, let's get into the first category, creational patterns. The name kind of gives it away, right? These patterns are all about how we create objects. It's about moving beyond just slapping the new keyword everywhere and instead getting some real flexibility and control over that whole process. So picture this. You're building an e-commerce site and you need to process payments. You've got PayPal, you've got Stripe. How do you handle creating the right payment object without just littering your code with a bunch of messy if statements? That's a classic problem. And the solution? It's one of the most common and, honestly, most useful patterns out there, the factory pattern. It's basically a central production line for your objects. Here's how it works, and it's pretty brilliant. Your code, the client, doesn't create the payment gateway directly. Instead, it just goes to a factory and says, hey, I need a payment object. That factory has all the logic, maybe a simple switch statement, that looks at the request and figures out, oh, they want PayPal, or okay, this one's for Stripe. It then creates the right object and hands it back. The beauty of this is that your client code has no idea that PayPal Gateway or Stripe Gateway even exist. It's completely decoupled. So what happens when you want to add, say, Apple Pay? You just update the factory. You don't have to touch the client code at all. That is huge. Okay, so that's creating objects. Now let's talk about putting them together. That brings us to structural patterns. These are all about how you compose classes and objects to build bigger, more flexible things. Think of it as using the right Lego bricks for your application. All right, here's a headache I'm sure you've run into. You've got this shiny new system, but you have to make it talk to some old legacy code. Your new code calls a method named send, but the old code has a method called sendMessage. They're supposed to do the same thing, but the names are different. They're incompatible. It's literally like trying to plug a European power cord into an American wall socket. It just won't fit. So what do? You get an adapter. And that's exactly what we have in software design. The adapter pattern. It's our universal travel adapter that makes incompatible things just work together. The magic here is this middleman, the adapter. So your client code talks to the adapter using the standard send method it expects. But inside, the adapter is holding on to that old legacy class. When it gets the call to send, it quietly turns around and calls sendMessage on the old object. It does the translation for you. Your client has no clue that any of this is happening behind the scenes. It's such an elegant way to make new and old code play nicely together. All right, we've created objects, and we've assembled them. Now for our last big category, behavioral patterns. This is all about how objects talk to each other and who is responsible for what. It's about managing the flow and communication in your application to keep things flexible. So let's go back to our e-commerce example. Imagine you're calculating shipping costs. You've got ground, air, maybe next day. The easy way to code this is with a giant if-else block, right? But what happens when marketing comes along and says, we need to add drone delivery? Well, now you've got to go back, crack open that core calculator class, and add more logic. That's risky. Every time you touch that file, you might break something. There's a much smarter way, the strategy pattern. This pattern lets you take those different algorithms, those different ways of calculating shipping, and turn them into their own little plug-and-play objects.
And this really shows you the night and day difference. On the left, that's the rigid way. One big class with a messy if-else monster inside. It's brittle and a pain to change. But on the right, that's the strategy way. You have a context, your shipping calculator, that just holds on to a strategy object. Need to calculate ground shipping? Cool, you just plug in the ground shipping strategy. Want to switch to air shipping? No problem, you just swap it out for the air shipping strategy, even at runtime. This is so powerful because it follows a core design principle. Your code is open to adding new shipping methods, but the main calculator class itself is closed for changes. That's a massive win for making your code stable and easy to maintain.
Okay, so we've looked at a few specific examples. Let's pull back for a second and look at the big picture. These aren't just abstract academic ideas. Think of these patterns as essential tools you're adding to your personal developer toolkit.
So why go to all this trouble? Because the payoff is huge. Your code becomes way more maintainable because anyone can see the intent. It's more scalable. Remember how we could add new payment or shipping methods without touching the core code? That's what we're talking about. You're not reinventing the wheel. You're using proven efficient solutions. And maybe one of the biggest benefits, you and your team get a shared language. You can just say, let's use a factory here, and everyone instantly knows what you mean. That's incredibly powerful.
And at the end of the day, that's what it all boils down to. It's about writing code that is maintainable, scalable, and efficient. It might seem like a bit more work up front, but it's really about tackling complexity head on so you can build software that lasts.
So I'm going to leave you with a little homework. Think about the project you're working on right now. Is there some giant, tangled if statement that's just screaming to be turned into a strategy? Or maybe some clunky integration that an ad actor could smooth right over? Or a part of your code where a factory could just clean everything up? The blueprints are here. Now it's your turn to go build something great with them.